So this is the video lecture for section 5.1, the Applied Calculus MAC 2233. And so in this section, we're going to be talking about increasing and decreasing functions. So let's define what that is. So let f be a function on some interval. Then for any two numbers, x1, x2, in the interval, the function f is increasing if f of x1 is less than f of x2. And of course, x1 is less than x2. So let me show you what that might look like here. So if I have, this is my function f of x. My x1 is there, my x2 is here, right? And so let's just say that f of x1 is there, f of x2 is there, and so basically the function is increasing here, right? So of course you can see that, of course, f of x1 is less than f of x2, and then also x1 is less than x2 because we're going from left to right. Now the function f is decreasing if f of x1 is greater than f of x2, but the x1 is always going to be less than x2 because we're going to go from left to right. So let's just make this one x1, x2. This is going to be f of x2, and then let's put f of x1 up here. And so what happens is that the function is sort of going somewhere like this, right? Let's just define it just to be that. Then you can clearly see that f of x1 here is greater than f of x2, right? And then of course x1 is always going to be less than x2. So you can see basically that's what it looks like. So the next thing we're going to talk about here is test intervals. So we can actually determine whether a function is increasing or decreasing or constant on a particular interval if we find a derivative. So if f prime of x is greater than 0, then the function is increasing. If the derivative of the function is less than 0, then the function is decreasing. And if it's equal to 0, it's just a constant. The next thing we're going to talk about is critical numbers. So if f prime of c is equal to 0 or f prime does not exist at that particular value, then the critical point will be f of c. So what does that look like? So for number 13, we're going to find the critical numbers. We're going to find the open interval where f is increasing and also where f is decreasing. So the first thing that we're going to do is we're going to find y prime. And then y prime simply becomes 3.4 minus 2.4x. So remember, we said we got to find where y prime is equal to 0. So we're going to go ahead and solve this for x. So negative 3.4 is equal to negative 2.4x. So 3.4 over 2.4 is equal to x, which is about 17 over 12. So what happens is that we create the interval here, right? And so let's put 17 over 12 right here. And so we're going to test a point on each side of this value 17 over 2. So this is going to be 0. And let's just make this, for the sake of argument, let's just say 2. So then what I'm going to do is I'm going to evaluate what the derivative when x is equal to 0, right? So y prime, so here's my interval. So y prime of 0 is going to be equal to 3.4 minus 2.4 times 0, which is 3.4. So then that means that the function is increasing on this interval. So now if we're going to find y prime of 2, that's going to be 3.4 minus 2.4 times 2, which is going to be negative 1.4. So this is, of course, greater than 0. This is less than 0. So then on this interval, the function is increasing. So it's increasing on negative infinity to 17 over 12. And then it's decreasing on 17 over 12 to positive infinity. And so that's how you do those problems. The next one I believe we're going to do is number 17. Yeah, number 17. I don't want to run out of space. I left it this way. So number 17, f of x is equal to 4x to the third power minus 15x squared minus 72x plus 5. So f prime of x is going to be 12x squared minus 30x minus 72, right? And so that's number 17. And so what we're going to do now is we're going to go ahead and factor out. So we're going to set f prime equal to 0. And so here we're going to take out a 6, which is going to leave us with 2x squared minus 15x. Minus 12. Minus 5x, sorry. So then this is going to factor to 2x plus 3, and then x minus 4. So then x is going to be equal to negative 3 over 2, and x is going to be equal to 4. So those are the two values that are going to, those are my critical numbers. So here I have my number line. I'm going to put negative 3 over 2 here. I'm going to put 4 here. And these are my intervals, right? So I'm going to find a test point in each one of these intervals. So that's going to be negative 2. I'm going to do that 0, and let's just make that 5. You don't have to pick some fancy values. So, sorry about that. So f prime of negative 2 is actually equal to 36, which is greater than 0. So the function is increasing on this interval. F prime of 0 is actually negative 72, which is less than 0, so the function is decreasing on that interval. And then f prime of 5 is equal to 78, which is greater than 0, which means the function is increasing on that interval. So the function is increasing on negative infinity to negative 3/2, and on 4 and positive infinity. And it's decreasing on the interval from negative 3 over 2 to 4. And so that's how you do number 17. All right, the next one that we have to do is number 23. So let's go over to 23. So 23, I have f of x is equal to x plus 2 over x plus 1. So f prime of x is going to be x plus 1 over 1 minus x plus 2 times 1 over x plus 1 squared, right? So remember, it's going to be v times u prime minus u times v prime, right? X plus 2, the derivative of that is 1. X plus 1, the derivative of that is 1. So then I'm going to have x plus 1 minus x minus 2 over x plus 1 squared, which is just going to be negative 1 over x plus 1 squared, right? And so that's going to be my derivative of number 23. And so since this derivative can never be 0, right? Because my numerator can never be 0. But it cannot exist at x is equal to negative 1. So now x, since negative 1 is not in the domain, then x cannot equal negative 1, but that's not in the domain of this particular function. So it's not considered a critical number. But we can still go ahead and do an interval, right? And we're going to do the interval at negative 1. So I'm going to pick 0 here, and let's just pick negative 2 there. So f prime of negative 2 for this particular one is going to be negative 1, which is less than 0. So it's going to be decreasing on on that interval, and then f prime of 0, it's also going to be -1, which is also less than 0. So it's also going to be decreasing. So f is not increasing on any interval. And then it is decreasing everywhere is defined. So it's going to be from -infinity to -1, then -1 to infinity. So that's how you do number 23. All right, let's jump over to number 29. So number 29 is y is equal to x minus 4 natural log of 3x minus 9. So that's number 29. So the function for number 29. So we're going to go ahead and find y prime. So y prime is just going to be 1, right, minus 4 times derivative of this function, which is just going to be 3, over the function itself, which is going to be 3x minus 9, right? So it's, remember, natural log of, right, if y equals that, then y prime is going to be equal to g prime over g of x. It's going to be 1 minus 12 over 3x minus 9, which would be 1 over 4x minus 3. We can clean this up a little bit more, so it's going to be x minus 3, x minus 3, 4x minus 3, which is x minus 7, x minus 3, right? And so there are two values here. Y prime is equal to 0 when x is equal to 7, 7 minus 7 is 0. And y prime is undefined when x is equal to 3. So that's not a critical number, but it doesn't exist. It fails to exist on that value, right? So here's my, so let's do 3 here, let's do 7 here. So here, I'm just going to go ahead and pick, you can pick any value. So we're going to choose a value from the intervals 3 to 7 and then 7 to infinity. The reason we're going to do that is because 3 is not, like I said, 3 is not a critical number, so we're not going to worry about that interval per se, or -infinity to 3. And so the other reason also is that we have to be careful. So any value that's less than 3, so 3 times 2 is going to be 6. 6 minus 9 is a negative. So we cannot get the natural log of a negative number. So that's why this interval, we don't worry about it, right? Because this will make the natural log of this, will make this negative, and we can't do that. That's why we only go from 3 to 7. And then from 7 to infinity. So I'm going to pick 8 there. I'm going to pick 5 there. And so, actually, let's pick 4. Make it a little easier. So y prime of 4 is going to be -3, which is less than 0, which means it's decreasing. And then y prime of 8 is equal to 1/5, which is greater than 0, which means it's increasing. So increasing on 7 to infinity, decreasing on the interval 3 to 7. That's number 29. All right, let's look at number 32, and the same thing for 32. So 32, f of x is equal to x times e raised to the x squared minus 3x. So that's number 32. And so y prime for this one, or f prime of x, is basically going to be x times e raised to the x squared minus 3x times 2x minus 3 plus e raised to the x squared minus 3x times 1, right? So we're going to use the product rule and then the rule of derivatives. So we can kind of clean this up a little bit, which is going to be ex squared minus 3x. And then, of course, here we're going to have the x, 2x minus 3 plus 1. So 2x squared minus 3x plus 1. Now, I can factor this out. So here I'm going to have that. And then here I'm going to have 2x minus 1, x minus 1. So then so f prime of x is equal to 0 when x is equal to 1/2 and when x is equal to 1. So those are my critical values, right? Critical numbers. So I do my intervals. So here's my 1, here's my 1/2. So I'm going to put 0 here. Here, let's just do 0.6, and then let's just do 2 there. I think that would be okay. So f prime of 0 is equal to 1, which is greater than 0, right? So it's increasing there. F prime of 0.6 is negative 0.08 over e to the 1.44, which is less than 0. So it's decreasing there. Oops. Let me do this again here real quick. That's my interval. And then f prime of 2 is 3 over e squared, which is greater than 0, so it's increasing there. So the function is increasing on negative infinity to 1/2, and then 1 to positive infinity, and then it's decreasing on 1/2 to 1. And so that's how we do number 32. All right, let's go over to number 45. I'm using the textbook here real quick. All right. So number 45, it's a word problem. So it says that a county realty group estimates that the number of housing starts per year over the next 3 years would be the following. So H of R is equal to 300 over 1 plus 0.03 R to the second power. So where R is the rate in percent of the mortgage, right? R is the rate of the mortgage. Oops. And it's in percent, right? So what they're asking us is, where is H of R increasing and where is it decreasing, right? And so what we're going to do here is, looking at number 45, we're going to find H prime of R. And H prime of R is just going to be the following. It's going to be negative 18R over 1 plus 0.03 R squared to the second power, right? And so since R is mortgage rate in percent, it is always going to be positive. So H prime of R is never going to be negative. So therefore, H is increasing nowhere. Now, if you think about it, right? Negative 18 times a positive number is negative 18. Negative 18 times a negative number is a positive 18, and it needs to be positive. And so therefore, it's decreasing. On 0 to positive infinity. Because R can never be negative, right? That's why it's from 0 to positive infinity. The next one is number 46. So number 46, it says that c of x is equal to x to the third minus 2x squared plus 8x plus 50. So it says, suppose that a total cost c of x in dollars to manufacture a quantity of x of weed killer in hundreds of liters is given by the function c of x is x to the third minus 2x squared plus 8x plus 50. Sorry. Take a quick drink there. And so where is c of x decreasing and where is it increasing? So here we're going to find c prime of x. Now c prime of x is 3x squared minus 4x plus 8. And so we're going to find where is c prime of x equal to 0. We're going to use the quadratic formula because we can't factor this. We get x is equal to 4 plus or minus negative 80 over 6. So since square root of negative 80 is not a real number, there are no critical points. So either the function increases throughout its domain or it decreases. So let's say that x is 0. So let's find out c prime of 0 is equal to 8, which is greater than 0. So then this function is increasing on its entire interval. So it's never decreasing because it turned out to be positive. All right, the next one is number 47. So number 47, it says a manufacturer sells video games with the following cost and revenue function in dollars, where X is the number of games sold for 0 less than or equal to X less than or equal to 3,300. C of X is 0.32x squared minus point, and I got 4 zeros, 1, 2, 3, 4, x to the third. The revenue function is 0.848x to the second power minus point, I got 3 zeros, 1, 2, 3, 2, x to the third power. So here we're going to say determine the intervals on which the profit function is increasing. So we're going to find out where c prime or p prime is actually positive. So then what happens here is that p of x turns out to be 5.528x to the second power minus 0.12316x to the third power, right? So remember, p of x is equal to the revenue function minus the cost function, right? That's what we did there. P prime of x is going to be 1.056x minus 0.12348x to the second power. So where is this equal to 0? Where is p prime of x equal to 0? So we're going to set this equal to 0, so 56x minus 0.12348x to the second power. So x, and then we get 1.056 minus 0.00048x. So then x is equal to 0, and x is equal to 2,200. So we have the interval, right? Let me just show you here real quick. So we know that we're going to go, here's 0, here's 2,200. Let's pick 3,000, and I believe it went up to 3,300, right? So that's basically the intervals, right? So 0, and then 2,200, right? So we're going to go ahead and pick 1,000, which is here, and then we're going to pick 3,000. So p prime of 1,000 is 576, which is greater than 0. P prime of 3,000 is equal to negative 1,152, which is less than 0. So then the function is increasing on the interval from 0 to 2200. So, all right, that's 47. And I'm going to leave 48 for you guys as extra. That's the end of 5.1. Thank you.